Hi everybody, today we're going to be doing an introduction to right triangle trigonometry. This video is going to include very basic examples and facts, starting with what is a right triangle, the parts of a right triangle, the Pythagorean theorem along with Pythagorean triples and examples to prove those, SOHCAHTOA, finding a side with SOHCAHTOA, and finding an angle with SOHCAHTOA. So first of all, what is a right triangle? First of all, it must meet the classifications of a triangle, meaning the angles add up to 180, and it of course has 3 sides. And what makes a right triangle different is that it must have one 90-degree angle, which is usually shown with a little box. So the parts of a right triangle would be first the hypotenuse. The hypotenuse is always located directly across from the right angle, which is a 90-degree angle. And then we also have 2 legs. The hypotenuse is always longer than both of the legs, so the hypotenuse will be bigger than leg 2, and the hypotenuse will also be bigger than leg 1. So the Pythagorean theorem is what we use to find the side or hypotenuse of a right triangle. And the formula we use for this is a squared plus b squared equals c squared. And to label these, this is always c. The hypotenuse is always c. And it doesn't matter which one of these legs represents A or which one represents B. So Pythagorean triples are 3 numbers that always plug into the Pythagorean theorem perfectly, and they always make right triangles. So I have here a list of all the Pythagorean triples, and we are going to do one example just to show you how this formula works and how it proves one of these correct. So let's do our first one, 7, 24, and 25. So first we need to label. If this was 25 and this could be 7, it could also be 24, and then this is going to be 24, it could also be 7, doesn't really matter. So we are going to plug this into our formula, a squared plus b squared equals c squared. So we have 7 squared plus 24 squared equals 25 squared. Now 7 squared is equal to 49, and 24 squared is equal to 576. 25 squared is equal to 625. And once we add our left side of the equation, we will get 625, which is equal to 625, meaning that this is in fact a right triangle, and it is a Pythagorean triple. And that will work for any of these as long as you plug in the largest number to the C. So next we have a concept that most people refer to as SOHCAHTOA, and SOHCAHTOA is used for finding a missing side or angle of a right triangle. It's also an acronym, which is probably the most important part. So the S, the O, and the H go together. The sine of theta is equal to opposite over hypotenuse. So if we had a right triangle down here and we are trying to solve for this angle right here, theta, we would say this is the opposite because it's the side opposite from the angle, and this is the hypotenuse since it is the hypotenuse of the right triangle. Next we have CHA, C-H-A, and that stands for cosine of theta is equal to adjacent over hypotenuse. And if we did this on a right triangle and we were solving for theta here, this is the side adjacent from the angle, and this is the hypotenuse of the triangle. So that would be how we solve for our theta. And then our last part is TOA, which stands for tangent of theta is equal to opposite over adjacent. And if we have a right triangle and we're solving for theta here, this would be our side opposite and this would be our side adjacent. So that's how we would solve for that. All right, now we're going to do an example finding a side of a right triangle using SOHCAHTOA. So say we are provided the following information. This side is going to be 5, and this side is going to be our unknown, and our theta over here is going to be 50 degrees. We do have enough information to solve using SOHCAHTOA, and first we need to identify what we know. We know our theta, we know our opposite, and we need to know our unknown, which is our adjacent. So since we have a problem involving our opposite and our adjacent, we are going to use tangent, or the TOA part. So we would have the tangent of theta equals opposite over adjacent. So tangent of 50 degrees is 5 over x. And to solve this, we can multiply both sides by x, and we will get x tangent of 50 equals 5. And then to solve for x, we would divide by tangent of 50. So we have x equals 5 over tangent of 50 degrees, and now we need to plug that into a calculator. One thing you need to be cautious about, especially during a test with this, is to make sure your calculator is in degree mode. There are several modes a calculator can be in. You'll probably be using degrees and radians during this unit, so you'll want to make sure yours is definitely in degree mode. And being in degree mode will get you x equals 4.2 approximately units, so that will be our adjacent. Next we have finding an angle with SOHCAHTOA. So say we know that our hypotenuse is 25 and we are solving for our theta, and we also know the opposite is 8. So we know the opposite, we know the hypotenuse, and we are solving for theta. So because we know our opposite and hypotenuse, we are going to use the sine or so, and we are going to do sine of theta is equal to opposite over hypotenuse. And then we're going to plug in the information we know. Now the tricky part about this is we can't just plug this into our calculator like we could the last time. We need to use something called the inverse sine, the sine inverse of 8 over 25, because using an inverse will get you your angle. So anytime you're solving for a theta, you're going to want to use that. And once you plug this into a calculator, you are going to get theta equals 18.7 approximately degrees. And that would be how you solve for an angle using SOHCAHTOA.